Hi guys, today we're going to do a slightly modified version of Geometry Wars clone that we did a while ago, which we called FX Wars game. So today we'll start using the newer version of FXGL, which is 007. There will be two links in the description. One will lead you to the all the jar files, so the latest one is 007. Just click on it and then click raw to download it onto your computer. The second link will lead you to the source code for this tutorial. So if you go to tutorial 24, you'll see the file which will contain all the source code for this tutorial. You can also, if you go back and go to assets, download all the assets for this tutorial as well. So textures and audio. Don't worry about data and text. This is for other tutorials. So once you've downloaded it onto your computer, open your project and right-click on it, create a folder. So it's new folder, call it lib, and then just drag it over there and click on OK on copy. Once you got your FXGL library in here, you can now right-click on the project's properties and then go to Java build path, libraries tab, and then this shouldn't be there, so you'll see just this, and you'll be able to click add jar, navigate to your project, and then lib, and click on the jar file of the FXGL library, and then click OK. So this will set up the whole thing. Now, once you've downloaded audio and textures, you need to place them under source code folder. So it should be assets. So you create a folder called assets, and then within that folder create another one called audio, and then place all WAV files in there. And then same for textures. You'll be placing all PNG files in here. It must be exactly the same, so the spelling must be correct in order for FXGL to load all the assets. And for today, we'll be using this package name com.your nickname.tutorial24, and then this is the single file that we'll be using, FX Wars app. Typically, all JavaFX start and entry applications, or entry files rather, are called something and then app to distinguish that it is the file where the entry point is. And our entry point is right here, public static void main, which just launches the game application. So that's pretty straightforward. These are the imports for today, and just to do a quick demo of the application, as you can see, I've slightly modified the game. So now we have sounds, we have bear animations, we also have animated sprites, and if you click space, you'll be able to sort of destroy all of the enemies on the screen. And then you can also shoot, as always. So whenever you kill an enemy, there will be a death animation. Whenever a bullet dies, you'll also see an animation. And yeah, pretty much that's it. Alright, so these are the imports for today. You might want to pause the video and then type them all. Well, actually, you have the access to source code, so you might not need to do that. So this is probably going to be a lengthy video, so I'll probably split it up into two parts, and in the first part we'll cover all the initialization and possibly spawning. So as always, what we're going to do is I'm going to go over line by line explaining what this thing is. what particular thing does. I've made a few modifications to the source code of FXGL, and the API is slightly different, but it should be alright to understand. Alright, so what we have here is the class name FX Wars app. It extends our game application. This is how you get all the methods and certain fields from FXGL. We now define an event, which is an enum that implements FXGL event type. So we can now create custom events. I'll come back to that eventually. These are our sort of fields to remember when something happened last time. I haven't implemented a proper timer yet, so we'll have to do this until a timer gets incorporated in the FXGL source code. This is our score property. Yeah, this is basically what you see on the screen. Laser alive is the Boolean property to hold true or false value and whether a laser is currently shooting or not. So laser is that thing when you press space. Laser bar is the thing on the top left. Actually, I'm going to do this. That should be easier to explain. So this is the laser bar that you see on in the top left corner. So this is this rectangle. Then you have FPS text, which is of type text, and this is where you can see it on the screen. FPS frames per second is the first value is the one that is being rendered at the moment, and second value is the performance, so potential number of frames that could be rendered per second. Then you have an entity player, which is the blue rectangle or the blue square. Then you have a random instance of a random object, a random class, so you can so it can create our enemies at random positions. I'm just going to kill all of them. Then we have audio clip instance, so sound, basically all our sounds are audio clips. So whenever you do something, there's a sound associated with it that could be played. Then we have assets, which is the object that contains all of our cached resources, cached assets like sprites, audio, and things like that. I've slightly changed how assets are loaded, so you don't have to load them manually one by one. You can now call them like so. So you can just call cache, and this will load all of the resources, all of the assets under these folders automatically. So you don't have to do it manually. Alright, so we'll start with the init settings, and this is the very first thing we typically do. We set width and height of our application title and then version. Yeah, that's it really. In our init assets, these methods which start with init, most of them are abstract from game application. So you need to override them, which means that you'll be providing the actual body of the method, so the code, which will be executed by FXGL at some point. And it goes pretty much like this. So it initializes settings first, then it loads all the assets. If there is an exception thrown within this method, the application will tell you something like couldn't load assets, and the application will exit. So by calling cache on asset manager, we get all the assets, or we get the assets object on which we can call different things like get audio, get text, get texture. Log cached simply allows you to see what files have been loaded. It's more of a debug method really, so you can see what you've actually loaded. you wouldn't call this in a release application. So yeah, we initialize our audio here. So we simply take each audio object and then initialize it to something that we get from the assets. And the file name that you put here must be exactly the same as in audio folder. So explosion, Powerup, shoot, etc. Make sure you don't make sort of spelling mistakes. Otherwise, it'll throw a null pointer exception because it will return null, and then you'll be trying to call something on a null object. You can also set volume to different sounds if you want to. Now, init game is where we initialize our game before we start. So what we have is our background, and we create a new entity of type background. We set graphics new rectangle, which occupies the whole space. So 1280 and 720. And we add our background to the list of entities. This is the very first call to add entities, and therefore our first object, or our sort of the most distant object, will be our background. So everything else will be drawn on top of that. We now call init collisions, and it should be pretty simple. We we add collision handler between type of player and type enemy. The order in which you define those things or pass those things as arguments will define the order of the objects returned in the callback. So if you say player enemy, you must also have the same order in the callback. And when there is a collision between player and enemy, we fire an FXGL event, so that's something new of API. And we create a new FXGL event and event death. And we define the event right here at the top. In fact, this is the only event we have. So it is more flexible instead of just calling destroy or something and writing your own entity object. You could create events, numerous events, and then just fire them whenever you need them. So player FXGL event, new FXGL event death, because we don't really care what the source of the event was. However, for enemy, we fire FXGL event, and then we pass a player object as the source of the event. I'll explain that later when we come to destruction animations. So for bullet and enemy, bullet dies and the enemy dies as well, but now we're passing bullet as the source of the event. So basically any event, any FXGL event has two fields, source and target. Target is the object on which you call the fire method. So this will be the target, and the entity that initialized the event or that triggered the event will be the source of this event. If you don't specify the source, then the target and the source are the same object. So in this case, it will be a bullet. Another collision handler between laser and enemy. So yeah, basically the same thing. We call new FXGL event death caused by laser. And our final collision handler, collision between player and Powerup. So whenever player and Powerup collide on the screen, we call FXGL fire event on Powerup event death. So we've registered our collisions. We now register our input or initialize our input, which is again straightforward. We add our key press binding. So we bind our W key to player translate 0 - 5. 0 is the X value and -5 is the Y value. That basically says move the player up by 5 units. Same for S, A, and D. It's just different X and Y values. Now our key type binding, so the difference between key press and key typed is key pressed is called all the time, as long as the key is pressed. Key type is only called once per actual physical key press. So space, space bar, if current time minus the last time shot laser. So basically the difference between now and the last time we shot a laser. If it's greater or equal to 5 seconds, then we can now shoot the laser again. So spawn the laser and then reset our timer. In the future versions of FXGL, there will be a proper timer to do this. So it will be slightly easier. And in our last call in our init game is spawn the player. Spawn player is here. So we set translate, so we already initialized our player at the top. So we now have an instance, initialized instance. So we translate X and Y. This is basically setting X and Y coordinate. This should be something like screen center almost. Set use physics to true so that the collision can happen between entities. And then we add FXGL event handler, which will fire when a particular event is triggered, and this event is event death. So when there is an event called death triggered on player, or player receives particular event, so I can do so by calling a fire FXGL event. This is the event object, and we can get target and source from that object. So the target is the player because we're calling this fire on the player. So we could have used a player instance instead of creating a new instance because it is essentially the same thing. However, if you're event handler in a separate class, so if you have a larger project and you define all the handlers in different classes, then you might not have this player instance in your class. So this is sort of a convenient way of obtaining a reference to the same player instance. So basically, whenever our player dies, we translate X and Y to a random position. We play our score animation minus 1,000, so basically when our player dies, you'll get 1,000 subtracted from your score. And then we play an animation, or play a sound explosion, sorry. So, yeah, this is the graphics for our player. As you saw earlier, it is just a square, blue square, and we set graphics to the player. Finally, we add it to the list of entities. Init UI is a little bit larger than usual. We have our text score right here. So yeah, on the right we have our score, which is this object. We bind its text property to score integer property, and we take it as string. So that essentially means whenever a score object gets changed, it will automatically change the thing, the text property of the text score, and this value will be automatically updated. Then we have our laser bar. We simply set fill to yellow-green, so this is the color of our laser bar. Then we have laser text, which is this new text space. We set font to a larger font than usual. Default is 12 or something, and we set it to 18, so it's larger and more visible. We set fill to color white, so basically color of the text. Then we bind its visible property to laser bar length. So as you can see, when I shoot the laser, the text space goes invisible because the laser bar is not full. And whenever it is full, space is displayed again. We also add listener to the visibility, to the visible property. So when the visible property is set to true, so whenever it goes to true, this is where we get new value of our visible property, or property visibility. So, and then whenever it gets set to true, we just play our sound. So whenever it gets full, sound will be played, yeah. Then we have our stack pane, which is basically a layout for our UI elements. We translate it to 50-50, position center so that everything is centered. We get children and add all to the list of children laser bar first, so this is the sort of background of our laser bar. And then on top of that, our laser text. And this is how it gets displayed, so that space, the word space, is on top of the rectangle. We then take our FPS text object, we translate X and Y, so it will be placed underneath the space, our laser bar. We set color to white, so the text is displayed in white. And finally, we'll add everything to the list of UI children. Alright, so that's for UI. An update method is, again, somewhat simple. These are pretty much our timers. So if there is at least 1 second between enemy spawning, then spawn the enemy. 5 seconds for spawn Powerup. 0.1 second for spawn trace. And the trace is that thing that goes after your player object. So basically trace. This blue rectangle which is not filled. And spawn bullet is if, so we basically do our timer thing, and then we also check if the left button of our mouse is pressed. We also set width of the laser bar to the minimum of 100, or if it is full or not. So basically we take the difference between now and last time we shot the laser, and then we divide by 5 seconds, so it is pretty much a percentage. So if we use our laser bar gets filled, and we don't want the value to go over 100 because we by default set it to 100 in X direction, so width. And this math.min method will return whichever value is less. So if it goes over 100, then this will be returned. And FPS text, we simply set text FPS plus. So we can concatenate the whole thing into a single string. This is the render FPS that you get from FXGL. So you don't actually define it. It is a field, protected field available from game application class. And FPS performance is the potential performance of your application. So how many frames per second you could actually render if you wanted to. But the limit is 60 frames per second anyway. JavaFX will limit to that. We'll try to. Alright, let's do our spawns, and then, yeah, that'll be it. So spawn enemy, is just that. Yeah, that's fine. So create new entity with type enemy. We set translate x and y to random position. Set use physics to true, so that we could do collision detection. Rectangle is the graphics, so it's a square 40 by 40, color red, set graphics to rectangle. So that should be very easy because we did that in the last version of FX Wars. So this is pretty much the same. Yeah. So we add control, new control. This is the behavior of our enemy. So how the enemy works, the enemy logic. Velocity is new point 2D. We could have used vector 2D, but there is no such class. So we use point 2D because it essentially represents, can represent vectors x and y magnitudes. And the methods also support all the operations on 2D vectors. This is our sort of timer thing. Last time change of velocity. If the difference between last time and now is 0.5 seconds or more, we then create a new point 2D, new vector. We change the velocity so it moves basically in a different way. And it will try to adjust to the player's position. So it will seem as if the enemy is following the player. And we do that by first taking x and y of the player, then subtracting where our entity is. So that gives us the vector between player and enemy. We normalize the vector, so it's unit length of the so that length of the velocity vector is of unit length, and then we multiply it by 2 to slightly increase the velocity. And then we reset our timer. And we, on each update of the enemy tick, we translate. Translate is basically move. Using velocity x and velocity y. And we also have a handler for an event, and this is the single event that we have. So whenever a death event occurs on enemy object or on an enemy entity, we first get the source, and this is what I was talking about when you supply what caused the event here, or what triggered the event, whether it's laser, bullet, or player. So we can now do things like we get source object or source entity, we get the type of the entity, and if it's a bullet, then we play a normal death animation where the enemy just is disintegrated into small particles. However, if the death was caused by a laser, then they simply disappear. The Y values are scaled and they don't disintegrate. And we can do this by just checking what was the source of the event. If it was bullet, play tip the normal animation. If it was laser, then play death animation laser. If it was player, then don't do anything. We do not need to destroy our entity. And finally, we add our enemy entity to the list of all the entities. Spawn bullet, yeah, fits in just perfectly. So we create our entity bullet, pretty much the same. We translate x and y to player x and y, but we add 20, which is the half of our square for player rectangle or for player graphics, so that the bullet will be shot from the center of player. So yes, you use physics to enable collision detection. The vector is the velocity vector, or basically where we're shooting at. We get XY coordinates of the mouse. We subtract then the position of bullet. We normalize it and multiply it by 8 to increase speed. All these values are pretty much flexible and changeable, so you can easily modify it to fit your needs. We set property vector to vector so that we could then obtain this object in the control. Again, we're thinking that this control could have been defined in a separate class, so we might not have access to this instance, to this reference. Angle is the angle between the x-axis and sort of the bullet vector, so that we could shoot it and then change. We rotate the sprite of our bullet graphics, so it will seem as if it goes the correct way. So it was sort of rotated. And we do so by just getting all the transforms and adding new rotate and then the angle. And this is the formula to calculate the angle to work in our particular case. So the control or the behavior of our bullet is really simple actually. We simply get the velocity vector, we translate our entity using the x and y values of the vector, and this is just a simple check so that the bullet doesn't go off screen. And if it does, then we fire FXGL event, and the event is death. And we do not care about the source of death. We simply pass event death, our enum, and that's it. That will automatically set the source and the target of the event as the same object on which we called this method, so the bullet itself. And at some point we define the handler. Yes, we do. Yeah, first of all, we create a rectangle with with 10 height 1. Color white is the graphics for our bullet, and this is where we define our event handler. And if the event death was triggered on this object, then we simply play bullet death animation and get the target of the event. And the target of the event is the entity on which we called it. Add entities bullet so that we could display it on the screen. And then we play sound shoot. So, because when we spawn bullet, we're shooting a bullet really. Trace is the thing that follows the player and creates a nice effect, which also fades. Yeah. So yeah, this thing that goes after player is its trace, and as you can see, it sort of fades into the background. And so we create our entity trace first, and then we define a particle. So the type is going to be a particle. We set translate x and y to where the player is. We then set rectangle 40 by 40, which is going to be our graphics for the particle. We set stroke blue, so we basically just draw it using a stroke rather than fill, because as you can see, the inside of the rectangle, it's not filled with anything. We set graphics rectangle to our trace entity. We'd add to the list of entities, and finally we do our fade transition, which is of duration of 1 second, and we're animating our trace object, trace entity. We set from value 1 to value 0. This is the opacity in percent, 1 is the 100% and 0 is 0%. So it'll go from fully visible to fully invisible. Set unfinished is when our fade transition finishes. we remove the entity from the list so that it is no longer displayed. And finally, we play the animation. Our last thing for today is almost last thing. We're going to do spawn laser afterwards. So spawn power up is we create again. So pretty much all the creation is very similar. Translate X, translate Y, set use physics to make sure it's collidable. We get texture from assets object because this is the object that stores all our cached assets. So get texture because the name of all the textures starts Powerup underscore something, and something is the value. So 0, and then we get random value between 0 and 6, and because we don't have 0, 0, we add +1 to it. 6 is exclusive, so it will be return 5 at maximum. We also add .png afterwards so that we can get the full name of our texture. We set graphics, and this is where we call to static animated texture, which means that there are 8 frames in the texture placed horizontally, and the whole thing will be played in just half a second. So we set graphics as a constantly playing animation. As you can see, it constantly goes through all the frames in the texture. And if I show you the actual texture, it is like that. So as you can see, there are 8 frames in the texture. You can download this from the assets, and you should actually do this so that the application can run. We add an event handler as always, so event death. We get the target, which is our power up. We disable collision detection so that it doesn't collide until the animation is over. Otherwise, you'll get very strange effects, like getting scores really several times in a single second or single frame. Scale transition, the length of the animation is going to be 1 second. We're animating our entity P, and then set from X and from Y 1, so it goes from 1 and it goes to 0, so it scales down. And if you can see, when you get to power up, yeah, it will shrink. And also it will play the sound of power up. When the animation finished, remove the entity from the list so that it is no longer displayed and can be cleaned up. Play the animation, also play scored animation. We give our P reference, which is the entity, so where this power up was, and 2000 is the value by which to increase the score. Finally, once we've defined our entity, add it to the list of entities. Last thing we're going to do in this video is spawn our laser. We first define our angle field so that we can keep track of the angle. We create a rectangle with 1000 and height 1, so it is that laser thingy, which is one shot from the left side. We'll still be able to cover most of the screen. Set fill of the rectangle color to yellow. Then we create our entity. You can actually chain up calls. So this is one of the new things in the new version of FXGL. Instead of doing this like send translate, set translate, calling on every, so typing the instance every time, you can simply chain calls. So just do this and then do that afterwards and do that. So and then just one semicolon afterwards. It will still return the type entity. So you position the player, position the laser where the player is, +20, which is half of the square, so basically at the center. Set use physics for collision detection and set graphics rectangle. We then get transforms and add new rotate angle so that it is rotated correctly. Finally, we set laser alive to true so that actually, why do we do this? Oh yeah, we do this so that this could run. This is a method to run a particular piece of code while something is true. So it's more of a while loop combined with a timer. Laser set position, so we keep setting position where the player is in case player moved since last time. We clear all the transforms. We add new transform, rotate ++ angle, so we increase the angle by 1 degree. If angle is 270, so we have done our full spin, that would be -90 to 270, that gives us 360. We set alive, or laser alive set false. We remove the entity laser from the screen. We set angle to -90, which is our default. And we play, or we run this code every so 2/1000 of a second, so it's very quickly, and while this particular condition is true. Finally, we add our laser to list of entities, and once we spawn the laser, we play our sound, which is sound laser shoot. This will be it for this part of the tutorial, so we'll do animations of deaths in the next part, and yeah, that'll be it. Thank you for watching.